share this particular session, which seems to have the theme of miscellaneous. So it's a catch-all, lots of good things. So we're going to start today, and I was talking to people at the door, and so that means that I did not grab my phone and introduce myself to the first speaker. I'll go a lot better. Our first talk is, help me out here.
Maarten Breddels.
Who's speaking on?
IPywidgets.
IPywidgets. Okay, let's listen to some IPywidget stuff, and then we'll field some questions. Thanks very much.
Okay, thank you. Welcome, everyone. I'm Maarten Breddels, co-founder of Widgety, and today I'm going to talk about IPywidgets, how to go from an experiment that starts in a Jupyter notebook and how to go to a data app that runs in production. So why am I standing here? I'm an IPywidget maintainer, so I deeply care about this project, the success of the project, and I really want this to make the lives of people using IPywidgets better, and of course my own life better using them. I'm also the co-creator of Voila, together with Sylvain, and that was really successful in getting IPywidgets outside of the notebook presented to non-technical users. And together with Mario Buikhuizen, who's also here, my co-founder, we created IPyVuetify together with Voila Vuetify that allows you to really create beautiful looking web apps using the same tools as IPywidgets in the Jupyter notebook. So this has been quite successful. We've been helping the Glue Jupyter project, working together with Domino on doing the Space Telescope Science Institute, who's also here, helping them, and Osler in getting like fully what we call Jupyter apps running and getting them working on production. And this has been quite successful, and now we teamed up and created a company at the beginning of this year to make this even like a larger endeavor. So what is our vision? So we basically want to start from the Jupyter notebook, and we want to scale the apps in size, because people, for various reasons, they start with an experiment, but they want to create like a full-blown app, which means that they also want to show it to like lots of users. So they want to go in like this part of the diagram. But we don't want this to be like a really painful experience. Like we don't want to be end up like this grumpy cat. We want to make this experience really smooth, so you feel more like this cat. So the outline, we're going to make a small app in the notebook. Then we're going to discuss what the issues are. And then I'm going to get you to this promised land of this happy cat in 2 steps. First, we're going to handle code complexity. So we're going to redo our app in a new framework, built on top of IPywidget. And that will probably also already make you feel like this cat. But we're also going to talk a bit about performance. It's not vaporware, it's really running. So I'm going to give some real-life examples of where we're using this new product. And we'll do a recap at the end. So those who've seen talks by me know that this is my lucky slide. Always works. So let's imagine that we have a series of images, and we want to do some machine learning on it, count the red and white blood cells. And we first want to make a training set. So we're going to create a small app for that. So these are the images, and we first want to select what image we want to count blood cells on. So we take IPywidget, we do a drop down, we pass in all the images, the initial value, we print it out, and we have something interactive in like one line. And this is happening in the front end. So I select 45, and it's synchronized to the back end. And now we select out the image we want to count cells on. We can use the image widget to display this in the next cell. But this is not something you could, for instance, you could run this on Voila and then ask like colleagues to count cells for you. But it's not interactive yet because it's not rerunning the cells. So if I change this drop down, it doesn't like re-execute the notebook. But you can make it interactive by observing the change in the drop down and then updating the widget. So this now is interactive. So okay, we're getting a small app. But the idea was to count. So let's make this easier and make a button with an on-click handler that mutates this global state and then puts in the widget how many counts we had. So now we're going to count, and I'm really fast at counting. So I'm like, okay, 15, 17. Yeah, I think you all agree, 17 red blood cells here. But I introduced a bug. Because now I select this one, oh, the count is still at 17. Okay. Already prepared the code for this. So this should work. So now, if I change the drop-down, the count gets reset. Okay, this is working. But this is just for the red ones. I need it for the white ones as well. How do I do that? Well, should I copy-paste, or should I find some pattern to reuse this? So let's recap a bit. So it's very easy to get started with IPywidgets. Like, you can just print them out in a notebook and work with them interactively. But what I've seen is that there are two main issues. Like this button, I couldn't easily make a reusable component out of it. And what we introduced is incidental code complexity. I'll drop the last point for now. So let's take a look at the code to really understand what's going on. So why does this complexity arise? I mean, this is a small example, but in larger apps, this is like one of the biggest issues. So each feature you add adds new state. So one of the state values here is the drop-down, the value for the drop-down you selected. Now we add a new feature, this button, for counting how many cells you have, second state variable. But now for every state transition, so any event handler, you need to keep the UI in sync with the state. So we mutate the count, but we also need to, so in red here, you see that we're kind of like copy-pasting the code. That's a bit of a code smell. And actually, I introduced this bug, and again, I had like a copy-paste of the code. So it's really this boilerplatey, like manual, keeping this in sync. And I was talking to Fernando yesterday, and he also said, like, this is quadratic complexity. Every feature you add, every component, they can talk to each other. And then many more things that result in complexity. So this kind of, speaking at least for myself, results in developers feeling frustrated, like you add a new feature, you forget one of these state synchronizations, and you kind of feel overwhelmed. At some moment, there's so many states and so many transitions that you basically can only give up. Project velocities go down, and they basically grind to a halt. So we want to fix this, but we really want to fix this in a really, really good way. So how do we get to our vision? So we want to get to the top right. We saw with Voila, we can already expose this to many more users, which is great. But conquering complexity is, I think, a really large problem in making larger apps. And then if we do this, we can again use Voila, or later on, we'll talk about a different solution to get an even better performance. So let's focus on how do we conquer this complexity. So maybe I should create some new libraries, a new paradigm. But every time I think about creating something new, this XKCD image pops up. It's like, okay, let's not do this. Like there are 14 competing standards, and now we're like creating the 15th. But the biggest problem is, would you trust me? If I say like, hey, this framework is the best, would you trust it? Would you build the next app in it? And a year later find out, well, it's actually not such a good idea. So let's take a look. Who's building UIs? So the JavaScript world is building really complex UIs using React, Vue, Svelte. And actually it's React that we could consider translating to Python, because it's not a markup like HTML-based language. It's really just code that we could translate to Python. The key features is it's declarative, and it's proven technology for 10 years. So people really trust that React solves problems. And something that I didn't anticipate actually is, I think I'm going to try this at the sprint, is Copilot GPT-4 really understands React well. So if you talk about React in a different language, it kind of knows what you're doing and what the patterns are. So I think I'm going to try this out on the sprint, the Jupyter AI project. So I'm really happy to announce today Solara at JupyterCon. So Solara is a React-like API for IPywidgets. It's declarative. that can reduce a lot of bugs. It's composable, so I can reuse UI components. It's inspired on React.js, but it's 100% Python. So there's no JavaScript in this framework. And we provide a lot of components already, like things like standard things you expect, like button and slider, like coming from IPywidgets for those who know, things for file downloading, displaying data frames, but it's reusing the IPywidget ecosystem. So we're not creating something new, we're building on top of the current ecosystem. And we solve some common challenges, such as a convenient way of using threading, cross-filtering, caching, etc. And something I'll show soon is the type-safe way of doing state management using what we call reactive variables. So let's see if this works a second time. Okay, let's read in the images again. I'm going to import Solara. You can just pip install Solara if you want to try. And now we're going to declare the state outside of our UI. So we're first going to create like what image we selected, the counts. And these reactive variables are just like containers for a particular value. So you can read them off. And here we're going to put this function also outside of the UI. If you write to it, observers can like get callbacks and like do things like re-rendering. Okay, let's get to the meat of it, which is basically components. So you write a function, decorate it, and then within this what we call component, which is inspired on React, you can use like things like select. And just to show you, like everything's typed, so that's really convenient. So we pass in this reactive value. So now there's like two-way binding between this image reactive variable and this this component, which is backed by an IPywidget. And then we display it. And then if this select component changes this reactive variable, because this component is using this reactive variable, we automatically re-render it and update it. So it's really a few lines of code, and you don't have to manually wire this up. Okay, second challenge, like how do we create this reusable button? Let's get this out of the way. We just give it arguments, like red for the red blood cells and the count. And this is a really simple button that we can use and more importantly reuse. And now you have these like standalone components that you can now compose together in a small app. And with way less code and almost no potential to introduce bugs, we create something larger than what I've shown before. Okay, so let's imagine that you're reading in some large files. You're going to deploy this on Voila. It just works on Voila because it's IPywidget based. But you see it takes a long time to execute because Voila is executing all the cells every time. So just priming you for the performance part. And as you can see, this is fully functional in Voila. Thank you. So we're halfway through our mission. So we can now create really complex apps using a proven technology based on React. So we did this using Solara UI, using a React-like API, and now like all developers and team leads are happy because we can deliver. But now let's focus on the performance. So why would it matter? Good user experience. If it takes a long time to load an app, that's just frustrating. People will use it less. Hardware cost depends on the budget. If the hardware costs are a large percent of your budget, it of course matters. If it's just 1%, it shouldn't matter. But what I think is more important is this lower operational complexity. It's much simpler to run on a single node and not have to worry about Kubernetes, etc. So part of Solara is Solara Server. So what's Solara Server? It runs on Starlet, fast APIs, on modern web frameworks, but it's using a single process versus one kernel per request. as is common in Jupyter and also in Voila. That means that you have no process startup, no import times, and you can share data. Like you can read in the file once and share it with all the users. But also take a look at the preheated kernels for Voila. That can also solve some of these problems. So for this, we use something called virtual kernels that kind of mimic what the kernels are in Jupyter, but just for IPywidgets. And we render an IPywidget. So we don't render a notebook. We just render one particular IPywidget and not all the cells. Okay. How do you use it? Just Solara run, then the script or the notebook, and then the component or the widget. So we render components and widgets. So we do Solara run. Let's take this one. And our component was named page, so that's kind of the default. And now it's taking a little bit of time because it's reading in this file for the first time. So startup in this case takes a little bit, but now it's super fast. You almost don't see the spinner. So this is quite a performance increase and a reduction of memory use because you're just reading in this file one time. Imagine having like 100 users, that would save quite a bit. Just to show it's functional. We also support notebooks. So it's sometimes you have some code lying around in notebook. We just execute the cells, so that's quite convenient. And we support normal IPywidget, but then we do re-execute the file for technical reasons. Just a graphical representation what's going on. So on the right you have like the Jupyter Voila way of doing things, which I think should be the default, because if you do stuff in the notebook, you may mutate global state, and like if you want something that acts exactly like in the Jupyter notebook, you should use Voila. But for every request, you will have to read in all the data, the images, the data frames, etc. So in Solara, here we have 4 requests. They go to one worker, one process, and they share all the images, all the variables. Maybe you think, well, oh, that doesn't scale, but you can always choose to use like GUnicorn with multiple workers. But the scaling of processes is independent of the number of users you have, so it scales much better. Production ready, it is running. So the Solara website itself is running on Solara. So this is all made using IPywidgets. Let's go to the docs. For instance, if you go to the quick start, you'll see an example here, and this is because it's Solara. It's a Solara example in Solara running on a Solara server. Like everything's live here, so you can like copy paste this, run this in your notebook, or try this out yourself. A really large project that we did together with Domino is Code Assist, Domino Code Assist. That's a low-code tool. So that's actually has a really complex UI. So they're really Solara shining because it makes it feasible to actually create this product. And you can use it to like read in data frames, do transformations, a bit like Bamboo Lib, but also create apps and deploy them using Solara. So we're using Solara to create the UI, and every component we created we can also use in the app deployment part. This is an interesting case. So they created a prototype in the Jupyter Notebook using IPywidgets, and they're now going to production. They have a startup, and they're selling this to clients now. So they're really going from the experiment in the notebook to an app in production. So okay, the recap of our journey. So we conquered complexity using a React-like API from Solara. All happy. We could use Voila. But if we want some better performance, we could use a Solara server, which is using Starlet, fast API, and using virtual kernels can render these IPywidgets. And then also the users and the ops are happy, and they all feel like this cat there. Awesome. So how can you help? I hope, like me, you see the potential in Solara. I really think it's the best way of doing pure Python web frameworks for larger apps. So we're really focusing on these larger, complexer apps. You can try out the tutorial and give us feedback at solara.dev. Maybe you want to try this out at the sprint. Maybe you want to do some user testing. Check out our GitHub. A star will be appreciated. And like on all these platforms, we did some announcements. So if you want to boost the signal, because I think it's really important to get this message out, because I think it's really important for the Jupyter ecosystem to show you can go from the notebook into production using the same stack. Also, if you are really interested in this topic, we are hiring, so come talk to me if you're interested in that. And thank you all.
Thanks very much, Maarten. Do we have any questions from the audience? Okay.
Quick question. The components can be linked across cells?
Yeah. Yeah, so let's take a look. Like for instance here, I could do, so because the state is also living outside of the components in this case, I could do, you see this, create these new components linked to the same state, so these are fully synchronized. Yeah.
Hey. I really love seeing this as someone who works mostly in React. It's really cool to be able to see that brought over here. I saw in the documentation that you have support for state. Are you also looking at other hooks as well that exist inside of React, such as like use effect?
Yeah. Yeah, so I didn't expect this, well, yeah, we have the full React API. So use effect, use memo, what else is there? Use ref, use context, etc. What we found out from user testing is that people get like put off at first. So people want to create apps. So we want to not show the hooks first and just say like, okay, there are these reactive variables, really easy to use. If you start making reusable components, then you want to start looking into the life cycle of components, caching things using use memo, etc. So all of these are available. Basically the full core API of React. Yeah.
So one of the things you showed in your demo previously was that if you change the image, just the counter resets. Did you implement that in this one yet?
Yeah, yeah. Let me show you where this happened. So if I change the select, so we have basically every trait in tradelets land kind of maps to an on-value event handler. So we say on-value reset counts, but we do all our state management outside of the components. So it's really nice because you can imagine having a larger app, like this is what you want to test, this kind of like application logic. And the UI is kind of just a few of that. So, yeah.
Hey, what could we do? Is this working? Yeah. What could we do in the Jupyter kernel world to enable these optimizations, reusing the kernel architecture to benefit from the multi-language benefits of Jupyter?
So you're saying could we do the same thing for other languages? Yeah, yeah. So I think so. My ideal design of Solara would be that Solara would be based on some library that enables just pure like lightweight kernels in Fast API or Starlet. But it turned out to be really difficult to entangle, and I had to implement some parts of the protocol. So I think it's now that this is working, it's maybe a good time to review. Like, okay, what parts of the protocol did I need to copy, basically, and can we like refactor the Jupyter libraries to make this really easy? And also, for instance, Bokeh is also capable of, or Panel, I should say, of rendering IPywidgets. So there are now like probably like 3 or maybe more implementations of part of this protocol. So I think it's time to to think about like refactoring this. Yeah.
Normally, when I'm writing web apps,
yeah.
it goes very badly, and I spend a lot of time debugging. Can you talk a little bit about what the debugging experience looks like for this? Am I looking in the JavaScript console? Am I adding Python print statements? If things go wrong, what does it look like to debug?
Things just don't go wrong. Yeah. It's. I think it depends. I think the most complicated stuff is if you want to make a reusable component and you're using hooks like use effect, etc. But that's more an advanced feature. If you're writing applications, I think in most parts, the things I debugged together with Mario that took us sometimes maybe an hour are basically transitioning your application to a wrong state. So you're doing two mutations, and then you get two renders. But one of the states is actually invalid. So you're doing a render that's actually invalid, but you kind of like encode. For instance, you can imagine that it's not valid if only one of them is 0. But then it renders, and then after this, it's valid. But in this meantime, you can get some, and that is something to be aware of. If you kind of hit that once, spend a few hours on that, you won't do that again. Then most of that's the biggest problem. For the rest, all of the other problems are my worry.
Obviously, this is going really, really well, but I can invite the next speaker to start getting ready in terms of slides or projector, and we'll try and grab like 2 more questions in this session.
Hi. So I had just a quick question. If Solara is made to build some kind of web apps in Python, does it support routing?
Sorry, does it support?
Does it support the routing, the routing?
Ah, yeah. So the Solara webpage itself is fully like it's like has multiple pages. If you want to see a more like simple example. There are some tutorials on how to do multi-page support, so it's basically multi-page and routing. We support like Markdown files and Python files, so you just put them next to each other in the same folder. Multi-page. I can't find the example. Ah, yeah. So here you have like the starting page, page 1, and page 2. And if you look at the source. No internet. GitHub issues. It's basically 3 files, and you just start Solara and give it a directory. It will read 3 files and does the routing for you. It's a problem that's more complex than I anticipated. So I'm glad that you don't all have to solve that problem. So good question. Thanks.
Okay, let's thank our speaker one more time. Lots of questions, lots of interest. I'm sure you're around and take more questions.